Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone, welcome to Bohdi Park NEET and J Academy. Today we are going to discuss 10 MCQs based on gravitation chapter in physics. So you can also download the app from the link mentioned in the description. So let's start with the first question. In this first question it is mentioned that a boy fall freely from the building of height 320 meter. So initial velocity 0. After 5 seconds, Superman jumps downward with initial speed u, such that the boy can be saved. What is the minimum value of u? So the concept here is the Superman should catch the boy before reaching the ground. Okay, so minimum value of u we have to find. So we have to consider the exact moment when the boy is touching the ground, the Superman will catch the boy. Okay, so let's draw the diagram. Suppose this is the ground level and this is the boy. It is falling 320 meter. So the moment it will just about to touch the ground, how much time it will take? So we can use S is equal to ut plus half at square. A will be minus g. So displacement is negative minus 320. So we can find the time taken. U is 0 for the boy. So we have minus 320 is equal to u is 0 minus half g t square. So this is 320 into 2 by 10 is equal to t square. So 64 is equal to t square. So t is equal to 8 seconds. So in 8 seconds, the boy will hit the ground. So the Superman should make sure that it will catch the boy before 8 seconds. Okay. So now this is the Superman. It is falling with the initial velocity u. Okay, initial speed u. So we will use minus 320 is equal to minus ut. S is equal to ut plus half at square. For that t will be 5 seconds less, because after 5 seconds Superman jumps. So the time taken by the boy is t. So the time taken by the Superman will be t minus 5. Then minus half g into t minus 5 square. So minus 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 cancel. So 320 is equal to u into t minus 5 plus g by 2 is 5. So 5 into t minus 5 square. Now the value of t we have found, it is 8 seconds. So 320 is equal to u into 3 plus 5 into 3 square. So this is 3u plus 45. So 320 minus 45 is equal to 3u. Now this is equal to 275, and that is equal to 3u. So u is equal to 275 by 3. So its value is 91.66 meter per second. So third option, finish. Now next question. Now look at this new question. A particle dropped from some height capital H from ground. After 3 seconds, particle is stopped and again dropped. So when it is stopped, the velocity becomes 0, and when it is released again, the initial velocity will be 0. It takes further 4 seconds to reach the ground. The total time of fall if the particle were not stopped would be. Okay, so understand the question. In the first case, the particle is dropped from height h. It is allowed to fall for 3 seconds, then it is catched, then again released. So after 3 seconds it will release again. Okay, and in next 4 seconds it is reaching the ground. So let's draw the diagram. So the particle is dropped from this point. Suppose this point is A and u is 0. Then again it is stopped at point B. So time taken is 3 seconds. And on the ground, suppose this point is C. So B to C it is taking 4 seconds. And the total height is h. So suppose B to C is x. So A to B is h minus x. So now we have to find the total time of fall if the particle were not stopped. So if the particle is not stopped, so initial velocity will be 0 and free fall will take place and it will hit the ground. Okay, so this time we have to find capital T. So if it is not stopped, we can use S is equal to ut plus half it square. So h will be equal to 0 plus half g t square, and t is capital T. So capital H is equal to half g capital T square. So we will find h first, then we'll put here, we'll get t. Okay, capital T. Now let's find h. So in 3 seconds it is falling h minus x, and in 4 seconds it is falling x. In both the cases the initial velocity is 0. So A to B we can write h minus x is equal to half g into 3 square, and B to C we can write x is equal to half g into 4 square. Now if you add these two equations we will get h. So add, so h minus x plus x is equal to half g into 9 plus 16, so this will become 25. So h is equal to g by 2 into 25. Now put this value of h over here. So g by 2 into 25 is equal to g by 2 into t square. So g by 2 cancel, t square is equal to 25. So capital T is equal to 5 seconds. So if the stone is not stopped in the somewhere in the middle, then it will take 5 seconds to hit the ground. So first option. Finish. Now next question. Now look at this next question, third question. A particle projected vertically up attains height h at 2 seconds and 6 seconds. The maximum height attained by the particle. So basically the height h is for 2 time instants. First time instant is 2, other time instant is 6. So from the ground it is projected vertically upward. So suppose this is the ground. The stone is projected with velocity u. So it is going up. So suppose this is the height they are talking about. So from t is equal to 0 to t is equal to 2, it is at this height, then it is further going up, then again it is coming back. So when it is coming back, it is at the same height at 6 seconds from the beginning. So suppose this point is A, this point is B, C, okay, this is C and this is D. So when it is going up, so A to B time taken is 2 seconds. then A to B to C, then C to D, time taken is 6 seconds. So that means B to C and C to D, time taken is 4 seconds. So that means B to C time taken is 2 seconds and C to D is also 2 seconds. What is the maximum height attained by the particle? And A to B time taken is also 2 seconds. So A to C total time taken is 4 seconds. So when it will come back to A, C to A, it is also 4 seconds. Going up time taken and coming down time taken is same. Okay, if we ignore the air resistance. So we have direct formula, the height fallen will be h is equal to half g into 4 square. If any ball is dropped from initial velocity u, which is 0, dropped means initial velocity is 0, so it will take t time to hit the ground, so h is equal to half g t square. So g by 2 into 16, so 8g, so that will be equal to 80 meter, maximum height attained by the particle. Done. Now next question. Now look at this question. A body is thrown vertically upward such that distance traveled by it in 5th and 6th second are equal. You throw any object in vertically upward direction. Topmost point velocity 0. You just imagine when it is going upward. So during upward motion, the last t seconds distance covered, and when it is coming back, so from topmost point it is coming back, the first t seconds, the distance will be same. Suppose this is the topmost point. The ball is going from this level and it is taking t seconds to go up. So same distance it will cover in next t seconds when going down. Now that t second is given as 5th and 6th second. So 5th and 6th second is 1 second. Okay. So in this t second, how much distance it will cover? Half g into 1 square. Okay. So that is equal to 5 meter. So in 5th second, the distance covered is 5 meter. In 6th second also the distance covered is 5 meter. So how much time it is taking to reach the ground from topmost point, or how much time it is taking to reach the top from the ground? Okay, both are equal. So if it is thrown with velocity u, so it is taking total 5 seconds to reach the topmost point. 4 seconds plus one more extra second, so that is 5 seconds. Okay, so again it will take 5 seconds to come back. So height will be equal to half g t square. So that is half g, we can write capital T here. So half g into 5 square. So 5 into 5 square. So this will be 125 meter. Total height attained, or the maximum height attained. So third option. Clear? Now next. Look at this new question. 5th question. A ball is dropped from height on the floor. So from some height ball is dropped and it will hit the floor. On colliding with the floor, it loses some of its energy. So definitely some energy is lost. So it will rebound with some new speed, and that speed will be less. So it will not go up to the same level, some less height it will attain. Which speed time graph best represents motion of the ball? So after hitting the floor, it will rebound with less speed, and the acceleration is minus g throughout. Okay, so acceleration is minus g, it is constant. Okay, so the speed time graph we have to find. Now when it is dropped, so speed is 0. So the speed is 0 in first, third and fourth option. Clear? So speed is increasing, definitely speed is increasing when it is coming down. So it is mentioned in first, third and fourth, speed is increasing with time. Clear? If you look at first option, this is the time instant when it will hit the ground. So just after that the speed is same and now it is decreasing, then at the topmost point speed becomes 0. So but according to question it is losing some energy, so the speed of rebound is not same. It is hitting with speed v1, so it is rebounding with speed v2, and v2 is less than v1. So clearly first is not the answer, it is wrong. Okay, now third, so it is rebounding with less speed, that is true, and as it is going up speed is decreasing, so definitely speed is decreasing. Okay, topmost point the speed is 0, then again it is coming back, so speed increasing. So this graph is looking correct. Now here fourth point, fourth option, when it is hitting the ground, just after that the speed is v2, but here according to this option just after hitting the ground the speed is 0, so that is wrong. The speed of rebound is not 0, it is v2, so fourth is wrong and third is correct. So finished. Now next question. Look at this new question. It is a sixth question. The two balls are projected vertically upward direction with same speed 60 meter per second at interval of 2 seconds. So one ball is projected upward. After 2 seconds, another ball is projected. The time from the projection of second ball after they will meet. So when they are meeting, their position will be same. So from the ground they are projected. So suppose they are coming like this, they are coming like this. So at this level they are meeting both the balls. So the height from the ground is same. Now for the first ball, it is going up, and after time t, between 0 to t, it is covering height h, and the speed is same for both. Okay, so suppose this is u, so we will write h is equal to ut minus half g t square, because initial velocity is upward, so positive, and acceleration is negative minus g, displacement is h upward. Now for the second ball, it is thrown after 2 seconds with the same velocity. So for second ball, the time taken will be 2 seconds less. So we will write h is equal to u into t minus 2 minus half g into t minus 2 square. Now both h are same. So we have to find the time from the projection of second body, means we have to find t minus 2, after which they will meet. So over here we can equate both of these, and u is given as 60. So 60t minus half gt square is equal to 60 into t minus 2 minus g by 2 into t minus 2 square. 60 t cancel, so minus 5t square is equal to minus 120 minus 5 into t minus 2 square. So 120 is equal to 5t square minus 5 into t minus 2 square. So this is 5t square, 5 common, so t square minus then t minus 2 whole square, so t square plus 4, so this will minus 4, then 2ab, so that is 4t minus 4t, so it will become plus 4t, t square cancel, so this is 24 is equal to minus 4 plus 4t, so 28 is equal to 4t, so t is equal to 7, so t minus 2 is equal to 5. Time from the projection of second body is 5 seconds, they will meet again. So done. Now next question. Next question is based on graph. Okay, so body is projected vertically upward with speed u. So velocity is upward and it is u. Velocity v versus position x is best represented. So x is the position, we can also consider it as height. So we have to find vx relation. So you see, when time is 0, x will be 0 and u is equal to u. So initial velocity is not 0 when time is 0, and it is going up, so velocity is positive and increasing, positive and decreasing. So in all the in first, second and third graph, velocity is decreasing, but in fourth graph velocity is increasing. So fourth is clearly wrong. Now next, the graph will be straight line or parabola or curved graph. So we have the slope, so we know that v square minus u square is equal to 2 into minus g into x. Okay, so height is equal to x, so we have v square is equal to u square minus 2gx. So clearly it is not a straight line, it is a parabola graph. Okay, it is not a straight line because the power of v is 2, okay, power of x is 1, so it is a parabola. So second and third option also wrong, so we have only one option left, that is first. So first is correct, it is a parabola. Finished. Now next question. Now next, 8th question. Water drops are falling at regular interval of time from certain height h above the ground. So suppose there is a ceiling over here, and from that ceiling the water drops are falling. Okay, regular fixed interval, maybe every 1 second drop is falling, next 1 second drop is falling, next 1 second drop is falling, so that is regular interval. At the instant fourth drop is released, the first one just reach the ground. So let's draw the diagram. So let the interval be t seconds. Okay, So when fourth drop, this is the fourth drop, is ready to fall, fall, the first one just reaches the ground. So this is the first, okay, this is the ground level. So basically the time taken by the first drop when the fourth drop is ready to fall is 3t. So you can understand using this diagram. Suppose when time is 0, so first ball is ready to fall. After time t, the second ball is ready to fall. Similarly, after time 2t, third drop is ready to fall, and after time 3t, fourth drop is ready to fall. Okay, so time taken by the first drop is 3t. So we can use the formula h is equal to half g into 3t whole square, and h okay, h is given h, okay, so we have to find the height of the third drop from the ground. So h we have found g by 2 into 9t square. Now you see, so second drop may be here and third drop will be here. So this distance, third drop has fallen for t seconds, and we have to find the height of third drop. So this will be half g t square. So the height of third drop will be total height minus half g t square. So height of third drop is equal to total height minus half g t square. Now half g t square we can put from here. Half g t square is equal to h by 9. So this is h minus h by 9. So this will be 8 by 9 h. That is our answer. Third option. Finished. Now next question. Now look at ninth question. So from the top of tower, a small stone is projected vertically upward with 30 meter per second. So suppose this is the tower. Tower means building. Suppose this is the building. So from the top, it is thrown upward, projected upward with 30 meter per second. It strikes the foot of tower. So suppose this is the foot of tower. So that is also the ground. This is ground. So in 8 seconds. So basically its motion will be like this. It is going up, then coming back along a straight line. It is going up, then coming back. Total time taken is 8 seconds, and initial velocity 30. So we have to find the height of the tower. If you observe, initial point is A, and on the ground the point is B. So it is going upward, velocity becomes 0 here, then coming back. So total displacement is minus h, if h is the height of tower. A to B, initial position is A, final position is B. So displacement is minus h. S is equal to minus h. Initial velocity is upward 30, so plus 30, and acceleration under gravity, acceleration is always minus g, okay, downward. So we can take a minus 10, okay, g value is 10, so acceleration minus 10. Now time is given as 8 seconds. So s is equal to ut plus half at square. So we get minus h is equal to 30 into 8 minus 10 by 2 into 8 square. So minus h is equal to 240 minus 5 into 64. So that is equal to 240 minus 320. So this is minus 80. So h is equal to 80 meter, height of the tower. First option. Finished. Now next question. Look at 10th question. A small stone is released from rest. So initial velocity 0 from the top of multi-story building. During its free fall, ratio of distances moved by it during first, second and third second. So we can use Snth formula to solve this question. Snth, which is u plus a by 2 into 2n minus 1. So displacement in first second, now u is 0, it is released from rest. So displacement in first second will be 0 plus a by 2 into 2 into 1 minus 1, and displacement in second n will be 2. So 0 plus a by 2, 2 into 2 minus 1, and third second, so displacement in third second is 0 plus a by 2 into 2 into 3 minus 1. So first second it is a by 2 into 1, and second it is a by 2 into 3, and in third second it is a by 2 into 5. So the ratio is a by 2 is to 3 times a by 2 is to 5 times a by 2. So a by 2 cancel. We can divide by a by 2 throughout. So 1 is to 3 is to, so required ratio is 1 is to 3 is to 5. Second option. Okay, finish. Thank you.